And the topic of my presentation is feature engineering and ensemble modeling for paper acceptance prediction. And this is joint work with Yingpeng Dong, Yema, Hailong Jing, and Zhuanzi Li. My introduction will include these 5 parts. At first, I will briefly introduce our idea and framework in the competition. Then I will talk about the feature engineering methods. And third, the models. Fourth, I will show some experiment results. And finally, the conclusion. Let's start with the introduction part. I think you know that this year's KDD Cup proposed a very interesting task, which is whose papers are accepted the most. Given any upcoming top conferences in 2016, the goal is to rank the importance of institutions based on predicting how many of their papers will be accepted. The ground truth will be determined by all the 4 research papers accepted in the conference. And the organizers defined the ranking policy. We call it institution ranking score. This task is very challenging. We have huge and heterogeneous data. We use Microsoft Academic Graph. There are millions of authors, papers, and many conferences and institutions in the dataset. We must figure out how to extract useful features for ranking the institutions. And the problem is very open. We can use both supervised or unsupervised approach to solve the problem. And the ground truth is unknown beforehand. And we all know that the paper acceptance of a conference is quite uncertain. So we cannot very accurately predict the paper acceptance. The organizers also encourage us to use other publicly available dataset. The main idea we used in this competition is to predict the institution rank based on the performance in recent years. First, we extract some statistical features for institutions. We use author level and paper level features to measure the performance of an institution in a conference. And then we expand the feature set with similar conferences. And we use 3 ranking models, and finally use the ensemble to obtain stabler results. This figure shows our framework. Our work includes first the feature engineering part, and then 3 ranking models. Finally, we use the ensemble for prediction. Okay, the second part, I will talk about our feature engineering methods. At first, we define basic features for each institution, conference, year tuple. These features are number of papers, number of authors, number of paper-author pairs, and number of first author, number of second authors, and finally, institution ranking score. All the features we used are statistical features to measure an institution's performance in the conference. And if we only use the 6 basic features we just defined, the problem is that considering only one conference can be very unstable and unreliable. So we assume that paper acceptance in similar conferences can help with the prediction. For example, if a university didn't publish many papers in last year's KDD, but instead they published their papers in SDM, WWW, or WSDM, we believe that they are still very possible to success in this year's KDD. So we use collaborative filtering to find these similar conferences and add the similar conferences into the feature set. Specifically, we first generate author conference matrix A, where Aij is the number of papers published by author I in conference J. So after we have this matrix, each conference can be represented as a vector. We can use the cosine similarity to measure the similarity of conferences. Right side is an example of our method. For example, there are 3 authors, A, B, C. They published some papers in KDD, ICDM, and SML. We can see that the cosine similarity between KDD and ICDM is much higher than that between KDD and SML. So KDD is more similar with ICDM. Here is the results of this method. We list the top 5 conferences of the 8 targets. We can see that the results is consistent with our knowledge. And we can also define the similar conferences by manually assign them but our methods can better measure the interior correlation between the conferences. For example, let's look at ICML. I think there is no doubt that ICML is most similar with NIPS, but we still find that ICML is similar with CVPR and KDD. You may ask that ICML is a machine learning conference, but CVPR is computer vision, KDD is data mining. I think it is because that some computer vision and data mining researchers will publish their theoretical works in ICML, and machine learning researchers sometimes like to publish their interesting applications in CVPR or KDD. So our methods can find this interior correlation between conferences, and we can use this information to help with us to make better prediction. And after we use these similar conference features in the feature set, another problem is that the feature dimension is relatively high. Let's take a look at our feature set for predicting KDD in 2015. There are in total 144 features. It is relatively very high compared with the number of institutions. So high feature dimension is usually harmful to the model performance. So we decided to use principal component analysis to reduce the feature dimension to 5. This is according to the performance in the experiments. Okay, the next part I will talk about the ranking models we used. We used 3 ranking models. The first, we call it baseline model. This is the most straightforward idea, which is use the average of recent years institution ranking score to predict the rank, and we used 5 years average. I think in the morning, Dr. Ma has talked about the effectiveness of this method. It is an unsupervised ranking criterion, and it's simple but very effective. Let's look at part of the scoreboard in phase 1 and phase 2. And these teams, I believe they are submitting the results of this model because I've tried the same thing and get the same result as them. And they ranked 64 in phase 1 and 69 in phase 2. So it shows the effectiveness of this model. And the second model we used is regression. We have already derived a feature vector for each institution, and we want to predict the institution ranking score Y, so it can be solved as a regression problem. In the competition, we use the average of linear regression and support vector regression. And the third model we used is ranking SVM. Ranking SVM is a well-known pairwise learning to rank approach. It trains the model using pairs of instances to learn which one should be ranked ahead. And the learning objective is just the same as the normal SVM. So all these 3 models can give the ranking score. So in order to combine these 3 models, we use the average of 3 model output for final prediction. So we do not use very elaborate ensemble methods here because we want to avoid overfit. And next, I will show some of our experiment results. We conduct some experiments to see the effectiveness of our model and determine the parameters. So we do conduct the validation experiments in this setting. We train the model using 2011 to 2013 to generate the input and then predict the rank in 2014. And after we train the model, we test the model using 2012 to 2014 to generate the input and then predict the rank in 2015. So these 2 parts we all know the ground truth, so we can evaluate. Note that we train the ranking model separately for each conference because the feature set is actually not the same because the similar conferences are not the same, so we train the ranking model differently. This table shows the results of different models. We can see that none of the 3 models can definitely outperform the other models because of the uncertainty of paper acceptance. But in average, we can see that Ensemble gives the best performance compared with single models. So it shows that combining 3 models can give us stabler results. We also compare the feature engineering method we used. We do the experiments in 3 settings. First, we only use the basic features to train the model. And second, we add similar conference features. And third, we further perform PCA to reduce feature dimension. The following figure shows the results. We can also see that the results varies in different conferences. So let's take a look at the average. In average, we can see that simply adding similar conference features does not improve the performance in our models. But after we performing dimension reduction, both 2 models has gained significant improvement. So we can conclude that similar conference features are beneficial for prediction, as long as dimension reduction is performed in our model. Okay. So finally, our team T310B have achieved the 2nd place in this year's KDD Cup, and I think it is an honor for me, and it is also very lucky. And I think there are many other ideas can be tried in this task, and I believe many of you have already tried these ideas. First, I think we do institution prediction at institution level, and I think we can also first predict the paper acceptance in author level first, and then move to institution level. We can also consider topic trends, and I believe co-author network and the citation network can also be useful for prediction. Okay, that's all of my presentation.